So welcome everyone. We have been going through this State of AI report, and the beginning of this first section talks about research. We're still kind of very heavy into LLM related topics, but the research slides are not all going to be about language models. So I think things may pick up speed, or they may slow down if people have more questions. I don't know. We'll see. But so we've talked about some of the trends covered here. And so this next one, this is slide 28 in the deck. Are we running out of human-generated data? So you guys, I'm not going to read it to you. You can read in here. But I do think that if you look at people are scraping the internet and all this stuff, you know, when like all of Wikipedia is considered tiny, then you know that we've already scraped pretty much what there is to be scraped. Any comments?
Isn't this the comment I would make is, isn't there also kind of this parallel discussion about, is it about quantity or quality? In other words, having a limited amount of human created data may not be important. It's, can we identify the quality data and figure out how to leverage that?
That's a really great point. I can't remember if there was a slide or if there's a coming slide, but yes, people are finding that quality for training LLMs is much more important. But the flip side to that is it's really hard to get quality data. Right?
Yeah.
So I believe one of the slides mentioned the textbooks are all you need paper, right? And so they trained on that and they found that, yeah, with a lot less training tokens, they were able to get really good quality because both the information content and the quality of the language, you know, the grammar, sentence structure stuff, those were both very high.
Right.
But once you've exhausted all textbooks, then where do you go for high quality data, you know? So that'll be very challenging.
I've seen some job positions pop up where it's like they want humans to write sentences, like actually just writing stories just for these machine models to learn on human text. So I think, yeah, you know, LinkedIn's been scraped, Twitter, all that, it's probably been scraped already, and you know, it's probably learning that data. But yeah, and I think it's about the use case as well. I think the use case of, hey, scrape Zillow for housing prices, I think that use case has been exhausted a little bit, and it's about, you know, finding that new use case that can generate a lot more value.
Yeah, so you can see they've got some pretty wide bars on here between 2030 and 2050. So I mean, you know, that's a 20-year difference. But yeah, even if they start using speech to text, we're still going to run out of text by 2050 is kind of what they're saying.
I had a question at this point. Is that okay?
Sure.
Right.
Yeah, go ahead.
So on ChatGPT, sometimes it asks you if the output was good or not, and you give a thumbs up or thumbs down. Is that incorporating reinforced learning? Does anybody know? Is that how they're making it better?
I don't know if any of us know.
Yeah.
Go ahead, Jerry.
I believe that is actually reinforcing to some degree the quality of the generation that it's putting out.
Oh, okay.
We talked.
I was thinking.
Go ahead.
I don't know how they've advanced since March. Okay, when they first rolled it out in March, my impression was the pipeline was still very manual. So if you give a thumbs up or a thumbs down, then some human might look at it and say, oh, that's a really interesting bad answer that you thumbs down. I'm actually going to pull it and manually insert into some training thing, you know, because I think it's a good thing that we want to teach it not to do, right? Or if it was a particularly good answer. But I didn't think it was fully automated where your thumbs ups and downs just like go into some pipeline. But I don't work at OpenAI.
And Ted, when we think of it from reinforcement learning, I think of that as different than filtering or improving the quality of the data sets. So in the scenarios you're talking about augmenting the data sets, right?
Yeah, I mean, there's two different data, right? There's the regular fine tuning, and then there's the RLHF. So yeah, so I guess it could be used for either, but if it was one where it's like poor chatbot performance, not necessarily factually wrong, then to your point, that would be a good RLHF training example.
Yeah.
So give it a really low score, or well, they don't have to manually give it a score, right? They could just throw it into their pipeline, and then yeah, they have human annotators that rate these things.
Right. So, but the human annotators would have to validate, if this person says, no, this is not good, they'd be the arbitrator of whether to accept that or not accept that
Right.
in that particular
just given
scenario.
the limited number of man hours of annotators they have to decide which ones they're going to include in there. And that's what I'm saying. I thought was very manual, but I don't know if they've advanced it since 6 months ago.
Well, there are, automated techniques to do this. And I suppose if with one of those, you could wire up, there's oh gosh, we talked about a couple of these. I'm trying to, RLAIF, right? So the artificial intelligence replaces the H in HF, the human feedback. So it's the AI feedback. So
yeah,
there is that, but I don't know how heavily that's being used. I don't think any of the big companies are betting their models on it yet.
No, that's just experimental. And in the original ChatGPT, if you recall, they didn't even use like Mechanical Turk. They didn't crowdsource this. They explicitly hired people on the payroll to do this work because they felt they needed to enforce a certain level of quality, which you can't get if you just use something like Mechanical Turk. So that's why I'm saying that just because like TED decides to thumbs up this, they won't necessarily find that credible. I think they need a filter to say, this is actually an interesting enough example we want to include in our training.
Yeah, I suspect you're right. It's probably like, has to go through first level screen, second level screen, third level, and then maybe we devote some resources to see if we really want to use this, information to make a decision.
Or anyone, do you know whether, what's the ramification of that? Does this mean that, in the past, our savior was more data? Now, if we have run out of data, then does it mean that one of the two, right? For the lack of better expression, like some kind of mode collapse in sense of the data, like this is the only data that can be generated now, or does it mean that there's scope to improve the architecture of or the models? So this is the data that we have. That's it. This is the amount of water we have. We have to figure out how to live with it now.
I don't know. My impression was because that 2021 date wasn't changing for a long time, right? That meant that their pre-training and fine-tuning was pretty limited, and that it was just the RLHF that they were trying to improve. And so from that, I'm not aware of any issues with too much data because you're training the reward model. It's just expensive because you're showing pairs to people that you're paying hourly, and then they rate which of the pair they like better. So the more, if you throw millions in there, then now you need millions of hours of people to compare all those pairs.
Yeah.
And there's the risk as well. Sorry, was that Quentin? Yeah, go ahead, Quentin. I can talk later.
No, I was just agreeing with Ted. We're going to have to find some type of way to generate more data organically so that, there's something else to learn on. That's all I had.
So when we say more data, is it like a different kind of data that doesn't exist? And that's why we need to generate more data, or the data exists. We just need to make it a better quality model from the data that exists. So I don't know. I'm just thinking out loud what this really means.
Yeah, I think when this slide is primarily focused on the pre-training, not as much on the fine-tuning, right? So
Right.
we're kind of running out of we had whatever that was, the C3 thing, the colossal whatever corpus.
Yeah.
And then it was like, oh, that's too small. you think you've scraped the whole internet, but you haven't really scraped every possible corner. So now we have the C4 that's like 10 times bigger than C3 or whatever. And it's still like, what are you going to do?
I think I'm with Dave on this, though. To me, it seems like, if I had a friend that knew everything in Wikipedia, I'd consider that friend pretty smart, pretty well informed. So I guess I don't understand why we need to have scraped all the human generated data, period, let alone let alone run it out. To me, it seems more like figuring out how to best integrate the knowledge that we do have, the high quality knowledge, into the model effectively.
Good point. So maybe you guys are right. Maybe we've gone as far as we can go, right? Because for a while there, people were thinking more and more data, bigger and bigger models, they keep getting better. But maybe now we're realizing that the quality of language on the internet is only so-so, and you're never going to get better, I'm
Kind of
not
signal the
thinking of the
noise.
right term, but like analytical thinking, you know what I mean? Like that kind of deductive reasoning, not that kind of thing. You're never going to get that, even if you had 10 times as much internet data to scrape, because the internet text just doesn't do a lot of deductive reasoning or whatever.
Or could it be like, could it be there be something related with like labeling? Because like now like data need to kind of like be humanly labeled, and there are still kind of like lots of mistakes in the labeling. And yeah, maybe like the source from the internet is kind of like narrative, and maybe we need like data from like conversations, so that if you want to kind of like the robot really talk with you, not just like someone on the internet, maybe like daily dialogue, something.
So I'm going to write down, last time we said we should write down papers that we might want to consider. So maybe we should actually consider that textbooks is all you need. Paper.
Yeah, I saw that one.
Because that kind of gets to what I think many of you are pointing to in terms of this theme.
That may be a good one. I don't know how many of you followed the Microsoft Ignite. They announced Phi 2.0 model, and textbook is all you need was the first one, actually, even before that, actually, and then we have 1.5 recently. So yeah, it maybe that's a good point, Ted. I just wanted to add one more thing about. So I'm looking at it from the point of view of impact, right? So let's say images, right? Let's say it talks about images also that it's not just the text, right? The third picture is the images, if I'm not mistaken. I'm trying to do it, right?
Yeah.
So if all the human images have already been consumed, and this is what the model produces now, and the newer images are now that potentially will be used by models in the future or seen by humans in the future are more machine generated images, it has an impact on how humans perceive vision. If like 90% of the data is not what you saw till last year, and the new 90% of data looks totally different, the new generation and the next set of humans will relate vision to that data. So I don't know if it has some other long-term effects as well in terms of the data running out and the new data getting generated, and overall on the society and even the cognition part for that matter.
Yeah. I'll hold off on saying too much here, but I think there might be a slide coming up, because there are those people who found that the computer generated images, if you use those as training data, they didn't work nearly as well as the actual images. So right now we're scraping the internet for images, but at some point people predict that more and more of the images on the internet will be computer generated instead of, true photographs. And so then you have to be very careful, because if you're scraping and they don't work, now it's not proved that they don't work, but if that does turn out to be the case, then I think it's likely to show up on a slide coming up.
Cool.
Yeah, you kind of poison your own database doing that. And that's actually a big problem is, machine learning models learning on machine learning generated information. But yeah, we'll go on to the next slide.
Yeah, so I don't know if that's what's covered here. That I have not read all of these slides, so I'm reading them along with you. So one thing they're talking about is people are trying to generate synthetic data. And so you can use that for RL, HF, replace the H with synthetic data, AI generated data, right? I don't know if this is going to talk about that thing. And I just heard people talk about it. I don't know an exact paper reference, but it said that, hey, we tried training this vision model with computer generated pictures, and it was much worse quality than the ones we trained on actual photos.
Yeah, I mean, data augmentation is really a last resort type thing. I mean, obviously it's not ideal to, you know, learn on something like that, but I mean, it's definitely another gear that you can turn, but it's definitely not an end all be all solution to the problem.
Yeah. You could, the third bullet gets to this point we've been talking about. If you read down there. This mode collapse, you call it.
So this middle one, it sounds like they said they generated some synthetic ImageNet and they were able to make ImageNet models better. But then this bottom bullet sounds like some of the cautionary stuff where you use synthetic data and at some point things start to break down.
Yeah.
So there's other flip side of the content generation also. So a lot of the language models that are coming out lately, those publish a benchmark, which actually is evaluation based on GPT-4 or something like that. So it's, even if the data that is trained on is human, but the assessment of evaluating or the benchmark, which is RLAIF in some sense, but it's not a feedback. It's just for now giving it a benchmark number. Oh, this model is good because GPT-4 assessed it to be more like a human-like content, which is kind of, you know, everything getting done by machines. So content created by machines, evaluated by machines.
Right.
So it's a tricky situation in my opinion, but I'm sure, you know, everyone or people who are doing this day in and day out are thinking about it as well.
Yep. So one of the trends is that our benchmarks are very imperfect, and also humans are expensive if you want to ask them to rate the quality of generation, right? You know, it's a lot easier with like a house price prediction model to judge how good is it, right? But when something's generating text, it's much more difficult. So yes, I have seen a lot of people say, hey, we can just use GPT-4 to judge how good the text is. And that's true, but it's only true for models that are worse than GPT-4. Once you get a model that's close to the quality of GPT-4, then GPT-4 isn't a very valid judge anymore.
Yeah, and that's a double-edged sword. I mean, that's a model evaluating another model. I mean, how effective can that be?
There's actually quite a few papers about it, just so you know. So they have found that what they would do is they would let GPT-4 judge, and then they would have humans, and they would check to see. And in fact, people found that GPT-4 did really, really well, and GPT-4 never fat-fingered it, never got tired and just started rating things badly. And so in the long run, GPT-4 actually beat the humans because it didn't make stupid mistakes. Not that it's actually like smarter, but like if you needed to rate, you know, 50,000 generated pieces of text, GPT-4 actually came out better.
Well, the other problem with humans is that humans have bias. You know, if you ask, you know, create this completion and it generates text, Ted, you may say, oh, it's item 2 that's better than the best one. And, you know, Shulin may say it's number 4. Yeah. So, you know, because it's an opinion question you're asking, you know? So.
Yep. Yeah. But GPT-4 does have its biases too, so.
Yes.
One of the things that I've heard in this regard is that it's easier for a language model to judge like which of the 2 responses is better than it is to have a language model generate the responses. So to me, and it kind of makes sense to me. So I can see how that would allow kind of this feedback loop between the language models to improve. Kind of like if you think about the way GANs work, right? Where that's actually just working against itself, and it improves.
Right. Yeah. Like I could have believed it if somebody did an experiment, and they said GPT-4 is a bad judge of how good another LLM is. But to your point, it is also very plausible that it could be pretty good, and multiple people have done multiple experiments, and they've shown that GPT-4 actually is a pretty darn good, accurate measure of how good your LLM is. So
there is a paper
if you're tweaking your 7 billion model and you want to see if it's a little bit better, if GPT-4 says, hey, it's 2% better, that's a good sign that your model probably is heading in the right direction.
So I think, Roger, just to your point, I think I've seen, you're right, I've seen paper where, or maybe a talk or something by Ilya, I think, where this exact point was made that, overall GPT-4 still is a better discriminator than, I mean, if there's any measure where you will, which is the better quality, then that's a better quality of it. Even though we are awed by its generative quality, but yeah.
And if it's a better discriminator, then it can train itself to be a better generator.
Which is a double-edged sword, training itself, yeah, but...
Yeah,
but the part it does easy.
So moving on, this is not something I've seen before this slide. So I don't know if you guys know, but like in pre-training, generally speaking, these LLMs only see any given piece of text approximately once. Yeah, sometimes you'll see that like Wikipedia, it might see it on average like 1.8 times or something like that. Higher quality content sometimes has a little bit higher sampling in terms of the training set, but generally speaking, it's around 1. So this slide appears to be saying, well, is the model going to be better if we actually let it train like twice? Because like ImageNet, people train over and over on the same images, but they do image augmentation. So you are rotating it a little, you're cropping it a little. So it's not really seeing the exact same image. I think people haven't really figured out good augmentations for text.
So essentially, sorry, I just want to understand those figures. So I think the middle figure is telling, right? Quite a lot. So as we go from left to right, we increase the epochs or the number of tokens, and the loss went down from 2.376 to 2.359.
Which of the 3 charts are you looking at?
The middle one. So how should I read that?
I'm not sure. What it's saying is that the black line is if you assume that going over 100 tokens twice is just as good as if you had 200 tokens of unique input. Okay, that's how you would expect performance to scale with the number of parameters. But in fact, what they found is that no, it's not as good, and that's not surprising that it's not as good, but it's not like catastrophic.
Ted, I was reading this as being that a smaller model trained on more data is better than a larger model trained on less data. And those, assuming that those two are the same compute budget, a smaller one with more data is better use of the compute budget.
Yeah, there's only 2 points, so it's kind of hard to really interpret this. I kind of feel like I need 3 or more points. But yeah, there's the smaller model thing, there's the more tokens thing, but then there's the repeat tokens versus all unique new text tokens. And I don't know how from 2 data points to interpret those 3 different phenomenon all happening at the same time.
Yeah.
So
Yeah,
I
I
think
guess
they
I
have
was
the
thinking of
yeah,
that as the amount of the data set, but you're right. It may be, given that it's about talking about repeating, it may be how many tokens processed, not how many tokens in the data set.
So generally, like when you increase the model size, the parameters, so you also need to increase the data, right? Because you will have more parameters, and so proportionally, one also needs to have more tokens.
Yeah, I think it's more of an art than a science. You know, as you see things are going one way, you make small adjustments to make them go the other way. And so it's just, I think it's about just an ongoing kind of monitoring of overtraining or overfitting. I think that would be most optimal.
I have a question. So if we have two models, one with kind of like 10 billion parameters, 10 billion parameters, neurons, or like another with kind of like 20 billion parameters, something. So, and we train it on the same data set, and after dropout, will they have somewhat a similar amount of neurons surviving, or they're going to be different? Because, yeah, so just because like after training, we use dropout to kind of like kill the useless neurons, right? So,
So
yeah, just
dropout is used during the training, but during inferencing, you go back to the entire model.
Right. Dropout is used for regularization, but neurons are not pruned in typical LLM pipelines.
okay. So the only problem, like if we use too small data set or too large model, is that there might be overtraining. So, could that be?
So there's two different phenomena that I think we don't want to conflate. Okay, so one is just model performance. So I'm pretty sure that until you get to real extremes, okay, if you say I only have 1 trillion tokens
Bless you.
and I can train either a 10 billion parameter model or a 50 billion parameter model, I'm pretty sure that it's always the case that the 50 billion parameter model will be better than the 10 billion parameter model.
Yeah.
Okay, so that is I don't care how much it costs to do it, what will give me the best model curve. Okay, what we've seen since the chinchilla paper is this idea of compute optimal. If what it's going to take you is 1,000 GPUs running for 7 days, would you have been better off training a smaller model on 1 trillion tokens rather than a bigger model on 500 billion tokens, and that kind of trade-off? And those are two very different trade-offs, okay? So it's not that smaller models are better, but if you have enough data, a smaller model with a lot of good data can give you, in the same amount of training compute, can give you the same performance as a bigger model trained on less data or something. That's
Yeah, and it depends on your use case too. Like if you're, trying to implement a model on a phone, you don't want, the entire like ChatGPT model on that phone. And so that's where the smaller model comes into place. You want a smaller model. I mean, and it doesn't perform at the same level, but you're not going to do anything mission critical from your phone. So it also depends, where the model is being implemented as well.
I think for that case, sorry, please go ahead.
Yeah, go ahead.
Okay, thanks. Yeah, like if I'm going to have a smaller model for specific use and maybe just use data from that specific field, maybe the data will be generated by GPT-4 or something. But yeah, I may kind of like build up like specific models, because when there's kind of like limited time and yeah, because like if the GPT-4 model is already so large, then why train the GPT-4 model? Why don't you just train a specific model for that small application?
I mean, you kind of have to take a step back and look at what are you using the model for? I mean, and it all depends, like, you know, if you're using this model to save lives, well, yeah, you want the big beefed up model to make the most accurate predictions possible, but like you don't always need that power. And so it's really you have to look at your own situation and just figure out, you know, what's best for you. And, you know, do you want a big model or do you need a small model? That's something
so
that you have to decide.
that's a
Also,
great comment.
so when you are evaluating the performance of the model, now on what type of a subject or a topic are you evaluating the performance of the model? Let's say if you are evaluating the performance of the model on a topic which is like, let's say, coding or any scientific information, or yeah, I mean, any biological information or scientific information where there is concrete truth to the data. Whereas there is a topic like politics, or where a lot of subjective, you know, point of views, different points of view come in, then it might, you know, those evaluations might be completely different. I mean, personally, what I see is that, for example, in coding, as of now, how much ever I have used a little bit of GPT-4 or GPT 3.5, it seems to be doing quite a good job. But when I ask it some questions, more like, you know, where there is no I mean, nobody can say this is the truth, right? In politics or in general questions about life, then obviously, like, it seems to be it gives its own answers, sometimes random.
Yeah, it takes a very
so that
authoritative
hits
stance.
one of the other themes, right? So our benchmarks right now are not that solid, and you'll see if you look at the benchmarks, right? Whatever, MMLU, Big Bench, they have different tasks, and so definitely depending on your use case. So if you have a chatbot that's going to answer frequent questions about your bookstore and what books you're selling, then you might prefer a different chatbot than if you had one that was selling scientific equipment, right? The one where you're answering frequent questions about scientific equipment might need to be, like you're pointing out, a little beefier on some of this understanding of some of the terminology and stuff like that. So that's definitely the case. And then I also wanted to just, from the earlier comment, just say, so I had mentioned two cases, right? One is just don't worry about how much it costs, what's the better model. One is compute optimal. And then the third dimension, which I forget, somebody made a comment. One of the other things that we see people talking about is at inference time, the smaller models are cheaper. And so if you said I could have two identically quality models, one's bigger, one's smaller, even though they may have different training budgets, I still might prefer the smaller one, even if it costs more to train, because it's cheaper at inference. So that's at least a third. I don't know if I'm leaving other ones out, at least a third dimension at which people are sort of making decisions for which model they want.
I never thought about that one.
Yeah. There's a lot of, if you look, there's a lot of people guessing what is ChatGPT 3.5, what is GPT-4 architecture under the hood and all this, because at the end of the day, even though OpenAI may have the money to build a trillion parameter model, it's actually super expensive for them to run inference on it. So they may not really want that.
So I have a question. So I wonder, like, if there are any studies done where, like, let's say if you train an LLM model just on medicine or biology related field, just on, let's say, on medicine. So well, how is it doing? Like, is it like, let's say you have certain model of a certain size, its performance versus when you increase the model size, does it do better, and in better in what way, kind of, you know?
Well, it's more accurate in its predictions as far as like, or like, let me think. If there's like a possible diagnosis, it's really good at doing that just based on like, symptoms of the patient. But as far as it's being adopted widespread in the medical industry, it's nowhere near that because it hallucinates, it's going to make stuff up. It takes a very authoritative stance. So it says things as it's fact. And so, and if it's wrong, well, who do you blame for that? And so, I mean, yeah, it can predict in some cases at a higher accuracy than what a physician can, but just as far as it being accepted socially by the community, it's nowhere close to that.
Yeah, I think your question was really focusing on the training corpus. And so the early data was that the GPT style models that are just predicting the next token, they need a huge amount of data before they get good at just basic language. So you could say, I only want to train you on biology stuff, but you might run into the issue. You don't have enough biology stuff for it just simply to be really strong at writing full English sentences, regardless of the biology content. So you might end up being better off with a model that was pre-trained on a much larger corpus, and then you fine-tune it on the biology data in order to make sure it has all of the technical content.
Yeah, I posted a comment in the chat about a model just got released yesterday by NVIDIA. They call it Chip Nemo. It's a Llama 7B, I think, fine-tuned. So pre-trained, as Ted mentioned, pre-trained Llama 7 billion model, which is whatever it cost Meta to get it out. And this Llama 2. And then they have internal chip design data. So they used all of that. Of course, you need all of that data as well on top of a pre-trained model. So you need good quality domain-specific data that you can train it on. And apparently it's being now used very heavily in chip design within NVIDIA and doing pretty good. So there are a lot of domain and specific problem targeted specific language models. I've mentioned a few times in this meetup in the past, MoveWorks has something called MoveLM, which is for IT service management problems, like what ServiceNow does, for example, but all automated through their language model. But again, pre-trained model, fine-tuned for the specific use cases. That scales much better than GPT-4, which is very, very costly for enterprises to use.
Yeah, and healthcare is mission critical. So you can't just leave it up to the machine to say, hey, this is this and it's not that, So it's always going to have to have a subject matter expert to validate if it's even right or wrong, because who knows?
Yeah.
All right. So again, in the interest of time, moving on to the next slide. This one's talking about people have already brought this up, LLMs for code. So I saw that in the chat. I don't know a lot about this topic. In my work, I'm more of a manager. I'm not coding as much these days. I still write some Python, some SQL, some R, but I'm not coding for many hours a day. So this is not. Anybody have any questions or comments on what's on this slide?
No, it isn't. It is a thing, though. I mean, all of the new, tools put out by Microsoft and everybody have, I'm looking at it inspects your previous code and it says, oh, you're trying to do a bubble sort or something like that. And it'll just blast the code in there, so.
Yep.
Yeah, I had some feedback here. It's really good. It's really, really good, especially the latest version of ChatGPT. And it's getting to the point for me that I'm coding a lot less and directing more. And I don't know if that's gonna hurt me in the long term, that I am delegating a lot of my coding work to this LLM. But at the same time, it's like this is a new skill that I'm developing. So
Mhm.
I don't know, maybe it's part of the transition. I'm not sure.
Yeah, yeah, I mean, but probably from day one of your coding, you've been using libraries that somebody else wrote that you don't really know what's under there, right? You call method XYZ or something like that, and it does something. And it could be hundreds or thousands of lines of code, but as long as it, computes pi to the 38th digit or whatever you want correctly, you accept it. So,
You know what's been happening the last couple of weeks
mhm,
is I found that I don't really even need to know what the code is doing, but I do need to know if it's doing what I want it to do. So now I'm getting good at telling the model, this is exactly what I want,
mhm,
and I want you to explain it to me, what
mhm.
code you write, and then I'm going to test it out, and then I feed it back any errors or something.
Mm.
And like that's kind of what I'm doing now. It's like I mean, like I feel I'm having imposter syndrome. Like, oh my God, am I even a programmer anymore? Because I feel like this thing is doing everything I used to do, and now what,
Yeah, but
So there,
once again, yeah, you become a manager of that tool essentially, right?
Right?
I'm
And
gonna agree with
Or
Jerry.
maybe
I mean, if you used to program in assembly and now you program in Python, you're not an imposter because you're not managing registers and all that crap anymore. You're just
Hey,
working at a
don't
higher
call it
level.
crap, Ted. I mean, I mean, I paid
So
for a house doing that.
so I think you should really embrace it and be happy with it. One other comment I wanted to make is I've seen people say that TDD works really well when you're using Copilot or one of these code models. So basically, the first thing you do is you tell it to generate all the test cases, then you tell it to generate the code, and so now you've got a really good TDD pipeline, and you didn't have to spend the time manually writing individual lines. But to your point, Abraham, you defined your coverage for, is it doing what I wanted it to do?
exactly,
Yeah.
yeah.
Abraham, I would say, a junior programmer would be handed a spec with test cases, et cetera, and they convert that to code. That part, the large language models may be able to do and more or less repeat. But a big part of it, a senior programmer's job is understanding requirements, writing the requirements documents, breaking down the problem into components, understanding what the implication of the design is and how it should be tested. Those parts we will now be able to spend more time focused on.
Yeah, I feel
so
like that's what I'm doing now. It's just big picture stuff.
Yeah.
yeah, but I want in my opinion is slightly bigger than that, in the sense that we, in our individual projects or smaller companies or startups that we may have worked in, uh, as against working in big companies, we are limited by the amount of data that we can train these models on. When I look at Chip Nemo, NVIDIA has been designing chips for so many years, so it has all the documentation of what is the specification of the chip that they're designing and the code. And now if you're able to train a model like that, then essentially a senior engineer's job is also being done potentially by a model like that. And to add to that, the context size is also increasing. So one reason why GPT-4 is even more effective now after the Dev Day announcement is because now it can handle a lot more of code than what it could earlier in one go. So not only is it looking at one file or whatever 4K, 8K tokens that it could work with, it could work with multiple files or let's say a whole repository more or less. And in parallel, if it has like in big companies, right, you write the functional specs, you write the design specs. Yes, they may be flawed, agreed. In a sense, they may not map one-on-one to the code, but someone can potentially use all the data to train.
Yeah.
Okay, I'm gonna keep pushing us forward.
Cool.
Did I go 2? Yeah. So I think this is referencing the paper that was in Nature, where they said the DeepMind folks figured out a way to get their AlphaZero model to optimize the assembly instructions that the compiler output for various different snippets of code, and they were able to generate better code than the current hand-crafted compilers. I think that's what these guys are referring to. And then there was the other paper where they looked at, well, there was the matrix multiply one, and then there's the sort one. So there's a number of different ones they did. I think that's the gist of what these guys are talking about on this slide.
One thing that they did not highlight, which is the last bullet here, is that matrix multiplication was a problem put to rest 50 years ago. And when AlphaDev found a way to improve it, a researcher improved it further. So a problem that no researcher was looking at. So it's a human and AI loop, which is a very interesting piece, which kind of gets hidden in this whole, just the speed up that they're talking about. And the reason I bring that up is I'm seeing a lot more of posts, including people who have fields medal, like Terence Tao from UCLA. Recently, he published a paper and he attributed to Copilot and all these tools which leverage AI underneath to help him prove the theorems. And this is the best of the best minds. I mean, a fields medal is the best you can get in mathematics.
Is that Terry Tao?
Say that?
Terry Tao, right? He used ChatGPT to help him prove mathematic formulas. Yeah, that was astonishing. Yeah.
Yeah, you're from UCLA, right, Shilin?
Yeah, from UCLA. Yeah.
Hey, go Bruins! Yeah, let's go on now.
I'm going to take away the moral that if a Fields Medal Award winner doesn't feel imposter syndrome for using ChatGPT to help him do his job, then none of us should feel imposter syndrome for using ChatGPT. Okay.
That's good.
Did you ask ChatGPT how to frame that?
It'll say, "Of course, that's correct."
If ChatGPT can help do lots of the routine jobs, because I feel like in mathematics, they do need the insights, which is provided by human, but there are lots of data, dirty words, doing the deductions, doing that from step 1 to step 2 to step 3, which are programmed, it's all the same. And I think that's the same with programming. There are lots of things okay, so if you want to print a sentence, it should be like this. And maybe at the start of the program, you import a lot of things, and the end of program, you output, you want to set some values to 0 or something. So maybe human can just be the plotter, okay, I want section 1 like this, I want the logic to like this, I want the sequence something like that. So this may feel that AI won't replace human, just helping human beings.
Hey, Ted, can I make one more point? Is that okay?
Yeah.
Yeah. Yeah, okay, thanks. So, I know Ibrahim and others, you have mentioned or shared your concerns about how GPT is doing a lot of coding work. The same thing happened around 2 years ago when AlphaFold came out, and it predicted the protein structures, not the not the polymers, but the monomers or whatever their definitions are. Before that, one protein structure identification used to be 1 PhD, more or less. So, I think almost everyone is going through that same thing and then figuring out what next. But that doesn't mean that field stopped. In fact, that is flourishing way more than, it has blossomed in the last 2 years with the drug discovery and application of AI in that field. I mean, if nothing else, that's a very good way to think about how and what may come, which we don't perceive or see right now.
Yeah, I am from a material science background, and I myself used to do a lot of simulations on just a few atoms, and with all these new discoveries, basically what we are doing is tackling bigger problems, right? Now we are able to imagine on working on climate change, through these through these type of discoveries. So a friend of mine is starting a startup in material science, using all these tools to discover new materials for like various applications. Now I saw Meta has been very interested in designing new catalysts for various reactions. So for example, all these poisonous gases or harmful gases that we have either from fuel combustion or various other processes. A big problem is, can we design the most efficient and cheaper catalysts? And now they are basically using all these llama and models to design these new materials. Yeah, so we are able to imagine to tackle kind of bigger problems now.
I think another research group in China, they just publish a method like how to predict, like how to synthesize materials.
Yeah. Yep. Which I mean, even just this 5 years ago, we wouldn't dare thinking about, these problems are so complex, right? Yeah.
Yeah.
Yeah, thanks for sharing. That is really very insightful. I mean, coming from your field, good to see that. That's awesome. Yeah.
Right.
Yeah. And I think we're going to see even more examples if we make it far enough to the slides. There's still a lot of research slides. This slide, so we actually in this group covered the Tree of Thoughts paper. That's on our YouTube library. So I think there might be some other slides on prompt engineering, but it's interesting because I personally feel like there's still a lot more for us to learn and understand in context learning and prompting. And so I've seen some people refer to current prompt engineering as a lot of trial and error, but one of the areas that we know that LLMs still struggle with is this high level reasoning. I don't know the right term, abstract reasoning, mathematical reasoning, analytical thinking, whatever. Like that's one of the areas. If you just want it to like tell you the 5 largest cities in France, you can probably do that. And if you do a retrieval model that has access to Wikipedia, internet, whatever, then if it looks at a source and the source lists different cities with their populations next to them, it's pretty accurate at picking out the 5 with the largest number next to them, right? So it's these more complex reasoning things that people are still trying to figure out how do we get them over the hump.
Hey, Ted, have you heard of this automatic prompt engineer? I assume that is a language model.
No, that's interesting. So it was to generate prompts for other LLMs, or?
Apparently, that's kind of what I'm reading there. That might be an interesting paper also to look at.
Let me write that down. I don't know that one. Dave, have you?
No. Thanks for bringing that up, Roger.
Oh, we got 2 papers.
Are there 2 things there? Auto COT and automatic prompt engineer.
Yeah. Oh yeah.
Yeah.
Yeah, auto COT doesn't really surprise me that much, but I'll write it down too.
Is that something that is familiar?
I don't know it, but I'm saying the idea, train of thought is like, break it down into smaller steps and whatever. So it seems to me that you could automate prompting something to do it in smaller steps. But I don't know.
It would have to know the rules.
Thing.
Wouldn't it have to know, I don't want to call it syntax, but where to make those breaks out?
Yeah, I'm sure there's more to auto COT than just, hey, break it into smaller steps. So there's got to be some cleverness there. But I'm just saying, to me, it's not really that surprising to say, let me build something that figures out
Yeah,
how to
yeah, to
train.
train a model to figure out where logically you would,
Right.
split this thing into pieces.
Right.
Yeah.
How to give
Okay,
it
I'm with you there.
examples.
Yeah. Yeah.
If you're doing few
Yes.
shot, how to give it some examples of breaking it into smaller
Right.
steps.
Yeah.
Yeah. I was talking to a researcher, and he was saying, hey, we're still trying to get LLM performance on GSM 8K to be pretty good. And then he was like, remember, GSM stands for grade school math. So basically we're saying that like LLMs do all these amazing things, and we kind of aren't past the 5th grade.
Yeah, this 8K is
word problems.
Exactly. So K8 is K to 8th grade. So it's up to middle school. GSM 8. Yeah.
Okay.
I thought the 8K was because it was 8,000 items in the set.
It probably is 8,000 items, but it goes till only till 8th grade also. So one way to remember that is
right.
8th grade.
So we definitely have a ways to go. Let's hear. Oh, here we go. Prompt engineering. So this is a little bit of a zing, a derogatory comment.
Yeah.
So he crossed out engineering and wrote trial and error. Okay. And so if your particular task is highly dependent on the prompt and that you can't get good performance right away, that's really kind of a problem. If you have a use case where like, it takes you 2-3 tries, you get pretty good performance, that's probably not a problem. This is interesting. How is ChatGPT's behavior changing over time as they keep tweaking it?
Yeah, but this is very controversial. So I don't know why they even would put that, because this came out around June timeframe, or they compared, right, March to June. But there were lots of questions raised about the test cases and whether that is a really a good way to compare. It's like one of those MIT paper about doing electrical engineering paper, and they retracted that later on. So to me, this one is controversial.
Yep.
Personally,
and we know that if you try to make a better chatbot, if you do RLHF, that right then and there hurts your mathematical reasoning performance. Right. So if you want to do analytical reasoning, don't use a version of ChatGPT. Use a version of regular GPT that isn't a chatbot. So so this one seems to me, but I do feel like a lot of what people do with prompt engineering is trial and error. Like, just try this and then try a few other things and see which one works best. Welcome, Agent Smith. LLMs, you're learning to use software tools. Yeah, so Toolformer, I think we did that paper here.
Yeah, we did.
Definitely the AI, OpenAI announcement, right? They've trained ChatGPT to be very consistent in making function calls. And so I don't know if it's 100%, but it's supposed to be very good. And so I do think that this will continue to expand the power of LLMs, and ultimately the fact that ChatGPT can't add 2-digit or 3-digit numbers shouldn't be a problem, because you shouldn't really depend on your language model to do the addition. It should outsource that to a calculator of some kind and various other things. And so, like, eventually I fully expect that ChatGPT is going to be able to like book, airline flights for me, but I don't need it to like do whatever. It's just going to call, some API to say, what are the available flights? And then it may have to do some reasoning to say, well, Ted would prefer the nonstop flight over the one where Ted doesn't like to fly through Dallas, blah, blah, blah. And then ultimately when it says, so this is the flight, and if I say, yes, I want that, then again, it's not going to scrape something together. It's just going to do a function call that says purchase flight.
So they already did that in their latest release, much of it. So if you recall, I don't know if people had GPT-4 subscription, Chat GPT-4. So they had a pull-down menu to select different subtools, if you may, for a specific prompt that you are going to write. So, hey, if I'm asking this kind of question, let me select the subtool and then ask that. So then it is calling that specifically. But in the latest version after the dev day, they have done away with that. They're like, we know what to call. So you give us the prompt and we'll know what to call. I mean, I'm sure they're refining it and improving it and more things are coming. But yeah, to your point, Ted, yes, this is already in
Yeah,
process.
like if you say, what's the weather in San Francisco supposed to be like tomorrow, it just knows a particular API and calls it. You don't have to tell it, use this, use that. And I'm sure for something rarer, maybe you do explicitly tell it, hey, there's this API exposed by blah, 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 that, you might not have heard of. Use that and help me do X, Y, Z.
Right.
Open-ended learning with LLMs.
Love the Minecraft.
I actually, one of the people didn't like this Voyager paper. So, it is absolutely true that people are doing more and more complex tasks and people are building agents and using Llama Index and using LangChain. So that I completely agree with. It just specifically the Voyager paper, they used GPT-4 to do very complex tasks in Minecraft. But the problem is they didn't use GPT-4 just as a reasoning engine. They used GPT-4 with all of its hard-coded knowledge about Minecraft. So like how many gazillions of websites and whatever about Minecraft are in the training set for GPT-4? So the fact that GPT-4 was like very quickly able to build tools and very quickly able to build a house and able to build a whatever portal, it's like, yeah, that's like, to me, I was just like, that is like not the least bit impressive. So there are other papers that are really cool papers on like reinforcement learning and other things where they took a model that knew nothing about Minecraft and got it to do more advanced things. This Voyager paper, they used an API that knows how to do everything. It knows how to craft, it knows how to move, it knows how to do all these things. It knows how to use the inventory. And then they just had GPT-4 tell it what to do. And it's like, well, duh. I mean, you could just like go to a Wikipedia page and have it tell it how to build a house in Minecraft and whatever, if you're just going to call this API. That's
in the
my
Voyager
personal...
paper, did they compare it to other RL approaches?
No. They were just like,
They
isn't
have
this
this...
amazing? We did these really complex things. And it's like, yeah.
But the last line there, right? It says unlocks key tech tree milestones up to 16x faster than prior SOTA.
With all the pre-trained knowledge of every blog on Minecraft ever written. That's not impressive to me, right? Anyway, I don't need to, I don't need to be right. I just didn't really get this paper.
Yeah, both that slide and the previous slide has a lot of overlap over reinforcement learning and optimization. And yeah, it's just interesting that
there was this
other world, that okay, now we're in the LLM world, but there's these other things about reinforcement learning and optimization which we need to look at and compare to.
Yeah, there was this interesting thing in this Voyager paper where they had a curriculum where they had it start easier problems and then they gradually had it do harder and harder things. But again, this is not like some GPT-4 that didn't know Minecraft, or where they like created an alt universe Minecraft where like the names of the materials were different and the tech tree for crafting was different. No, it was just like on regular old Minecraft that GPT-4, like, I think it could have, you could have probably just say to GPT-4 right now, like, what are the steps to create a diamond axe? Tell me, number 1 1, 2, 3, 4, step by step, and probably can just spit that out. So like, how is that impressive? All right, sorry.
I mean, I wonder if they could use this for like, football. Like,
Yeah, that's the
here's
analogy
my
that they
set
were
of
trying to
players,
make.
and give me like I'm the offensive coordinator. Give me the next,
Right.
here's the other team, and this is their strength. Give me the next play.
Right. That's kind of where they were going. But I feel like, again, when you have all of this written material on the internet about Minecraft, it's not that impressive. It was more impressive, like Cicero learned to play diplomacy, and they didn't inject, if I remember right, they didn't inject any human bias as to how it should play diplomacy. It just got to get trained on a certain number of games to sort of see how things worked, and then ultimately, came up with strategies and stuff like that.
Yeah, it's
so
a
to
very
me,
good point.
That's the more, and there are other Minecraft papers where they again took models that had no prior knowledge of Minecraft and figured things out.
On the RL side, on the flip side, is anybody aware of like where, if you know these things, like information from blogs or whatever, is it possible to infuse the RL with that information? Or is the RL always going to start from scratch and do its own exploit to figure it out?
There are a lot of papers coming out in the recent past that are adopting that. So if you look at the slide on the top right, there are these symbols which says text to tools. And Ted, if you're able to point to that, maybe people can look at that as well. Thank you, Ted. Yeah. So essentially, and to your point, Jayant, if you look at the title of the slide, reasoning with language models, planning with a world model. So essentially, there is work going on where the knowledge that is out there, both vision and text, not just the language. In this case, they're talking about language, but even the visual vision or the images. And can that be used to, and instead of using a robot to train and get that data, can that be somehow this whole knowledge and information out there be tapped into your RL flows and frameworks?
Cool.
Is that your question? I think that's your question, right?
Yeah. I mean, even that figure there, it looks very RL. You've got an environment, you've got an agent, you've got states, action.
Yeah, except now that world model is your language model. And that's something that Ilya has talked about a lot, that, well, he believes that GPT-4 has a knowledge of the world model with, whatever training it has had so far. So more training and more refinement will improve its world model. So,
but yeah, I can't think of any specific examples, but I think there are research papers where, like, if you give it not the real world, so like, what are those text-based adventure games, Zork or whatever, right? Like, I think people are saying there's enough reasoning capability that LLMs, if they play for a while, can actually get very good at those kinds of things, even though it's a completely made-up world that, well, assuming that you didn't already have like the walkthrough of how to win at Zork in your training set, if you just gave it a completely new one of those. GPT-4 outperforms RL algorithms by studying papers and reasoning.
we need to do this paper.
So should I write down Spring? I'm not familiar with this one.
Yeah, we should definitely look at some of these.
Okay. I wrote that down.
That's quite amazing
have any
that it can do that through a paper.
Yeah.
Now, that, what is it, 27%?
Oh, this, yes. I vaguely recall hearing someone mention this, right? So it's not just RL where you say, okay, I dropped you in this world, you know nothing, now go explore and figure out the rules, right? It's like, oh, I'm going to give you this academic paper, I'm going to give you the like sort of instructions, but obviously the instructions are not that complete, right? So it's given some information about it, but it has to fill in a lot of blanks and extrapolate a lot of things. And so that's where it's like, wow, it did successfully sort of deal with the fact that, yes, we gave you information, but it is pretty incomplete.
And in,
yes.
I guess the other ones in the table are all reinforcement learning. Dreamer, PPO.
Yeah,
Yeah.
Dreamer is
These
these look like
sound RL. So in those cases, you would have to set up your observations, your rewards, all of that. I guess in this case, you don't have to do any of that. You just throw it this paper that somebody else has figured out.
It's not a complete apples to apples comparison because those RL models didn't get to read the academic paper. They only got dumped into this world with no knowledge. But you might find that a lot of real world scenarios look more like this, where you have some information. And to your point, we haven't figured out how to inject that into a PPO model, but we absolutely know how to inject it into an LLM. You just stick all that text in the context and off you go.
Right. Yeah, it's pretty cool, this thing.
That's why I'm really big on LLMs. The guys who regularly come in the meetup, have probably heard me say, language was developed in order to be sort of the universal way of describing anything, And if we fail to be able to describe something, we just add a few words to our vocabulary until we now know how to describe it. And so I'm very optimistic that once you can do language, now multimodal, this, that, new worlds, you have access to this because anything you need to tell it, we as humans have been using language in order to tell other people things about anything.
That's interesting because, then it leads to another question like, is it also reflective of the language itself, like English versus some other language, like,
it's
like
a good point.
The battle of the LLMs, an English LLM versus a Bengali LLM or something.
That's a very good point. That's exactly what I was thinking, and even though English is universally spoken language now, but despite whatever biases people may think I have, but yes, some Indian languages have more richness in some aspects, right? So both in terms of vocabulary and expressions, and similarly, English has over Indian languages. So, in some aspects, so that's a good point. Yeah.
Well, I'm going to think of a really dumb example. I don't know if you guys think this is valid, but like if you were building a text to image model and you wanted like wintry scenes with snow and icicles and different whatever, like, is it possible that like Russian, Swedish, Norwegian to image models instead of English to image models, there just might be more richer vocabulary for describing some of that stuff, that wintry stuff?
Yeah, I was thinking beyond physical stuff, but yeah, like more abstract.
Right. Yeah, maybe Hindi has more like metaphysical descriptors than English does.
Yeah. A simple example, if I recall, Eskimo language had a unique word for, I don't know, a couple dozen different types of snow. So yeah, in that case, that you'd be able to describe a winter picture more richly with whatever the Eskimo language is.
Yeah, I was avoiding that one because I've heard things and I can't tell if that's an accurate example or if it's a urban myth.
Could be. Yeah, I can't cite it.
Yeah, I'm okay with no snow, but yeah.
That's why you live in California, Dave.
Do you notice that Dave isn't living in like North Dakota? What is this? Visual instruction benchmark.
Yeah, so look at the symbols on the top right. So it's the vision plus language to generate language.
That's interesting. I've
Wow.
never seen that use case before.
Yeah. All right. So we definitely know this multimodal stuff, right? Image to text, text to image, image plus text to whatever, you know. We're just going to keep seeing more and more of this. And so, yes, somebody's going to get like a paper for creating new data sets, new benchmarks. I don't think of that as very glorious, but without him, we would really be up the creek. Researchers wouldn't be able to measure their models.
So Yannick did a video on Blip too, and he invited the authors from Salesforce to do that also. So we probably should look at it. It was, and it's not a very, like, as you said, right? It's not a very flashy paper, but it is very useful, as you said.
Yeah, I mean, if you have like maybe a disability, maybe, you know, you might feed in an image and say, you know, what does this look like? I could see somebody using it for that.
Oh yeah, I was totally psyched. So Jerry, I think you were looking at in a future meetup, us watching the OpenAI Dev Day keynote together.
Yes.
And he mentioned that multimodal ChatGPT is being used by this organization called Be My Eyes. I used to volunteer for them. So a blind person can go on the app and they'll get randomly assigned a volunteer based on what language you speak, what time zone it is, right? But so if you feel guilty, like constantly asking your brother or constantly asking your neighbor to like look at something and help you, then the idea was that you're just crowdsourcing this whole bunch of volunteers. You may never get the same volunteer twice. You don't have to feel guilty like, oh God, this is the third time today I needed somebody just to tell me like, what's the expiration date on this particular item in my refrigerator, or I have a system where I like knit, and so I have the red yarn on the left, the blue yarn in the middle, but I dropped them and I just need somebody to tell me so that I can reset them to where I know they are, right? Those kinds of things. So apparently now they're able to service a lot of those requests just with the multimodal ChatGPT, and you don't even need volunteers.
That's cool.
I think that's super awesome.
All right, we are at it is 8 p.m. folks.
Okay.
So do we.
All right. So it looks like we've gotten to the portion of this deck where we're no longer talking about just LLMs. We're now getting into some of the multimodal stuff or whatever. So we can pause here. This is, for reference, slide 42. There's, I believe, 100 slides in the research section. 90 something. So I don't know if we want to keep going the number of weeks it would take to go through all of them.
This has
we'll have the new state of AI report by then.
We'll have the 2024 one by the time we get through 2023. So yeah, we
but it's cool. I mean, I really enjoy the conversation that we're having.
Yeah, I think we're having a pretty good group discussion. So I don't, we should continue at least a little bit longer, maybe. At least that's my vote.
So I'm going to stop. Possibility.
I'm going to stop the recording.
Yep.
Okay.